Okay, so hello everyone. Welcome everyone, and thanks for participating in this workshop. So we'll get it started. Okay, this 8-week workshop is sponsored by the UMI Metal Casting and Foundering 4.0 centers. During the presentation, please mute your audio and then ask the questions in the chat window. The video will also be recorded and sent to all audience members after the presentation and once it is ready. Okay, so let's get started. Before we start the workshop, let me introduce myself a little bit. My name is Jinzu, and a professor of the electrical engineering technology in the Department of Applied Engineering and Technical Management at UMI. So I joined UMI in 2005. So it has been a while. My research interests are in the area of the wireless, has been in the area of the wireless sensor networks and embedded systems. So about 3-4 years ago, I started to get involved with that industrial IoT research and then development for some of the projects for the UMI Metal Casting Center and Foundering 4.0 centers. So today, I'm very glad to have the opportunity to share with you some of the things I learned through the process. Okay. So as I mentioned earlier, this 8-week workshop. Today, today is the first workshop. The goal of this workshop is to help you to learn to build a few low-cost IoT solutions with some off-the-shelf components and then open source software. Okay, and today we'll have because it's the first one of this 8-week workshop, we will have some introductions. Okay, we'll first briefly discuss the concept of Industrial 4.0 and Industrial IoT, and then have a look at the Industrial IoT architecture and hardware components. We will discuss some general hardware platforms that we used for this workshop and then how to set them up. Okay, which is including the Raspberry Pi and then some Arduino boards. Okay, so let's first look at the Industrial 4.0 concept briefly. This figure just summarized the industrial revolutions over the past 250 years, ranging from that mechanical to the electrical and to the internet and then to the current fourth industrial revolution. Okay, the first industrial revolution is used to describe the integration of advanced technologies such as IoT and big data, artificial intelligence, advanced robotics and automations into the manufacturing and the other industrial to improve the safety, efficiency, and the productivities. The term of the Industry 4.0 was first introduced by a group of the German manufacturing high-tech strategy researchers back in 2013. So it's about 10 years ago, and led by the Dr. Kagman. Okay, the goal is to create smart factories that are highly efficient, flexible, and adaptive. So based on the result of a survey conducted by the MPI group in 2022, among the manufacturers who are adopting smart industrial 4.0 strategy, 63% of them reported that they have increased profitability, and 61 believes it is a competitive differentiator. Okay. And in this figure, it listed, in this diagram, it shows the various components of the Industrial 4.0, okay, such as the AI, big data, cobots, or autonomous robots, mobile technology, Internet of Things, advanced wireless communications, clouds computing. So those components are closely related to each other. They are integrated together to help accomplish the goal. Okay. For example, in order to apply the machine learning or artificial intelligence, we will need a lot of data from the manufacturing process. So Internet of the Things then can help with the sensing and data collection using the advanced wireless communication technologies. Okay, so our focus in this workshop will be on the Internet of Things, or IoT. So what is Internet of Things? Okay, we all know the Internet enables people to connect and interact with each other, no matter if they are in a single room or 1,000 miles away. Well, the Internet of Things allow not people, but also objects or things to have the ability to sense its surroundings, to interact and collaborate with each other, okay? The idea of IoT is to connect just about everything, every physical devices, such as we're showing over here, to the internet in the real time that allows data collection, exchange, and analysis. So let's have a quick poll. Okay, let's have a quick poll. How many that Internet of Things or the IoT devices, connected device worldwide in 2023? You could just use the link, which I can send also over that chat window, and then see how many devices do you guys think is connected? Are you be able to click on the link? Okay. Okay, great. Okay. Has everybody got a chance to guess, to enter the answer? Okay, so that's yeah. I saw data keep changing. Okay, nice. Okay, so let's look at the actual data. Actually, we have like 33% of people guessed correctly. That's amazing. Okay, so we can see over here, this is the current data. It shows in the 2023, there are around 15 billions of IoT devices are connected worldwide. Okay, it also provided a projected number. The number will be almost doubled by 2030. Okay, by 2030. So that's a lot of the devices, right? So the IoT is the key enabler of the Industrial 4.0. When we talk about industrial IoT, it means that we apply IoT technology into the manufacturing and other industrial processes. In the industrial IoT, the physical devices that are embedded with sensors are connected to the internet, allowing the data from the manufacturing process or other process to be collected, exchanged, and analyzed, and also allow the actuators to take actions. And then company can use those data for the real time or the offline analysis to drive the faster and more accurate manufacturing decisions. The whole thing can also certainly integrated with the big data analytics and predictions, and also for the AI applications. Okay, so the application areas not only range with for the limited to smart manufacturing, but also range in different sectors such as transportations. Okay, for those smart logistics or that smart grids for the utilities. Okay, so a wide array of applications. So in this figure is just showing one modern funding system examples. Okay, in this figure, we can see over here the AGV, the automated guided vehicles, or the conveyor on the figure on the left of this figure, and that can carry the molds up to a metal furnace, where then the robot can pour the molten metals into the mold cavity. Okay, the robots can help to improve the efficiency and the reliability. Sensor signals then are used to measure and control the solidification rate. The casting produced on the right side of those final products is subject to the examination for detection in, and then a feedback system is used where the input parameters can be optimized. A healthy casting depends on the variations of the process parameters, like pouring velocity, solidification rate, and accuracy of the motor design. All those information about this each individual operations can be collected via the IoT and shared on a cloud server. With the help of the AI, then it's possible to map the input variables of the casting with the soundness of the cast. And those parameters can be optimized for improving the overall process. Okay, so here let's have a look at this industrial internet reference architecture that is published by the Industrial IoT Consortium in 2022. Okay, we will mostly focus on these functional domain. Okay, on this functional domain. So we can see in the lower level is that control and the monitoring domain, including both the sense and actuations. Sensing is the function that reads the sensor data from sensors. Actuation is the function that writes data and a control signal to an actuator to enact an actuation. Control is the function in which the closed loop feedbacks are implemented. That includes sensing, performing the control computation, and also actuation. Okay, so there's three things in this the control and the monitoring layer. So the control calculation involved, including the understanding of the states, conditions, and the behaviors of the system under the control, and those of the peer systems. The complexity of these control computation varies greatly depending on the exactly application scenarios. The computation capability commonly refers as that edge analytics. So those are general evaluated locally in those local control systems for those real-time applications. Okay, but the IIoT system tends to be complex systems, including many function components that are loosely coupled and distributed. So the system management, okay, you see over here, there's on the second layer, there's three domains, management and then information and application domains. So for that system domain manages that overall these systems. The information domain then is the collection of the function for gathering data from various domains, mainly from the control and then monitoring domain, and then transforming, persisting, and modeling and analyzing those data to acquire high-level intelligence about the overall system. So that's for the information domain. While for the applications, this subdomain is for implementing the application logic that realize the specific business functionalities. Okay. On the top is the business subdomain. That business subdomain implements the business logic and interact with the back-end systems. Okay. So that's the overall architecture. Also from that same reference architecture, they including the summarize the IoT component capabilities. Each component may have one or more capabilities. So we see over here, there's some actuating, sensing, data transferring, data processing, data storage, storing, and and also some of the application interfacing capabilities. So some of the components may have one capability, some may have multiple capabilities. Okay, so let's look at one more question before we look at the hardware platforms. Okay, so this question is asking you in this IoT reference architecture published by the Industrial IoT Consortium, which of the following is not a function in the control and monitoring domain? You can again use the same. The same link should work. Looks like all people selected correctly. Okay, great. Yeah. So indeed, okay, well, for the control and the functionality and the monitoring domain, including both actuation, control, and the sensing. Okay, those functions are included, but not the measurement. Okay, great. So the IoT components, the hardware can generally be divided into different types, okay, that on the control and the monitoring domains, okay? The general devices are all the IoT gateways. Yeah, it is the link on the chat if there's any poll later on, we have any questions using the same link. Okay, so for the general devices or that IoT gateways, they have the capability to handle, to processing the information. And another important thing is to provide the connectivity capability, okay? That's going to allow the end devices to connect to the internet, okay? Because many of the sensors, it does not have the capability to connect it to the internet. So we're going to use those devices to connect with the sensors and then allow the sensing the data to be transferred back to the internet, okay, to the servers, to the cloud. Okay, so then the different type, another type of devices are those end devices. So they are including the sensors, which measures a sensor is a device, measures physical quantities such as temperature, pressure, location, image, okay, those information, and then convert that physical quantity into an electronic signal, okay. Actuators then allow the the components to take actions based on the command sent by the decision-making systems. So there's only many different kinds of components available. Some are black box components. That means you don't know how does it run. Manufacturing, some of the company already made the specific functions, so you can just use it, can run. Some of other components are open source. So what we over here today is we're going to focus on those open source components for the general devices. We'll talk about sensors in the later workshops. Okay. In this slides is just showing a general organization of the different components. IoT gateway, if the sensor with the networking capability, they could also send back the information directly to the cloud. Okay, so that's the information. So as I mentioned, today we're going to focus on talk about the general devices or the IoT gateways devices has the IoT gateway capabilities. Okay, that including we will talk about Raspberry Pi, and then we'll talk about some of the Arduino devices. Okay, so let's look at the Raspberry Pi first. Raspberry Pi, I think most of you guys at least heard about it, if not used it, is one of the most commonly used platform. It is a very popular Linux-based single board computer system. Okay, it's open source and is really affordable. It is developed by the Raspberry Pi Foundation, so you could check all different kinds of information through this link. The first Raspberry Pi module is actually introduced back in more than 10 years ago in 2012, okay? And then later on, we will see, we'll just have a look at the two. There's many different versions, but we'll just look at two of them, okay? One of them, the Raspberry Pi 4, okay, Model B, this is one popular one. But that's not the latest one, okay? The latest one is just come out, the Raspberry Pi 5 just came out last September. So this one is already pretty powerful. They support both Ethernet, you can see over here, Ethernet port, and also support the 802.11 AC Wi-Fi, and then also the Bluetooth. And then they have some USB port. You can connect it. You can connect it through those micro HDMI, the micro HDMI ports to connect it to your computer monitor or the TV displays. Okay, and then also provide a micro SD card so that you could plug into there. Okay, that is Raspberry Pi for Module B. Another one, which actually I used for most of my projects, is using this Raspberry Pi Zero wireless. There's different versions. So Raspberry Pi Zero, if you purchase, please make sure you purchase with that Raspberry Pi Zero W, okay, with wireless. Without the W, meaning it does not have wireless capabilities, which is not so convenient. So it is a small size. You can see over here, that's just a quarter. So, and it's a pretty powerful considering the cost. Only cost you can purchase online for $15. It does including 2.4 gigahertz and Wi-Fi, be it, IEEE 802.11 BGM support, okay? So, and also support the Bluetooth and Bluetooth low energy. So it does not have for, as many as that Raspberry Pi 4 or 5 as interface over there. So you can see over here, they only have one micro HDMI and one micro USB 2.0. Okay, so not as powerful, but it will be really sufficient for most of the projects. Okay, one of the things I want to mention over here is that power consumption. So it depends on your application scenario. If you want to monitoring some of the system which is next to your power supply, okay, the outlet, the utility outlet, that's fine. But many of the applications you may, okay, how about I want to have it battery powered? So the power dissipation could be an issue and consideration. We'll see the more powerful board, more computation power, then they will actually consume some more power. So depending on what is your application scenario, you need to choose the appropriate model. Okay. So for example, over here, you can see the Raspberry Pi 0W, and it is going to the typical billboard current consumption is 150 milliamp. Well, for the Raspberry Pi 4 Module B or the Pi 5, there's going to around 600 milliamp, which is 4 times more. Okay, so it won't be issue if it's plug-in, but if it's battery powered, you know, that's something you probably have to take into consideration. Okay, so I also want to mention over here, there's also recently the Raspberry Pi introduced a new board. It's called that Raspberry Pi Pico. Okay, Raspberry Pi Pico. It is not really the same. It's not the single board computing system anymore. So it typically does not really run the Linux system, but more like microcontrollers. That is what we're going to discuss for the Arduino. So Raspberry Pi Pico is more like Arduino boards. Okay, I want to mention that. So how to set up a Raspberry Pi? You can easily get a Raspberry Pi online, you know. What we will see for the general use, if you want to use the Raspberry Pi as a single board computer, then you will need to connect Raspberry Pi to a monitor, right? So you can see it. And also need to connect keyboard and the mouse via the USB ports, right? But for the IoT purpose, mostly of the application, we prefer set up that Raspberry Pi as a headless Raspberry Pi. What does that mean? That means we don't need to connect monitor, mouse, or a keyboard. So it's less overhead for the Pi, and then could have improved the performance. Okay, you don't need dealing with the graphic interface to the user anymore. Okay, you can remotely access that Raspberry Pi. Okay, that system, the Linux system, via wired or wireless link. I mean, I would recommend using the wireless. Simply, it's easier. You can move the things around it. You can access there anywhere, right? Even if there's no Ethernet cable available. So we will have a look at how to set up a headless Raspberry Pi. Okay, you're going to need a device. One of that Raspberry Pi device has that wireless communication capability, so Wi-Fi, okay, including Wi-Fi function, basically. And then another micro SD card, okay? I would recommend you get 8 gigabytes or larger. And for example, you can easily get a scan disk, 16 gigabytes of the micro SD card with like $6, $7. So very affordable. And then here's just showing the different steps. We'll just quickly look at over here. I will also send out these handouts to all the group after presentation. So you can follow the steps and don't worry about it. So this is I would recommend you to use the Raspberry Pi image. Okay, to download, they will give you these options. These are just the newest version 1.85. So it will ask you to choose the device, which is make and it's easier, so you don't have to make a decision which operating system you need to pick. You just select device, then it will recommend an operating system. You just choose the recommended one, and then choose the storage, which is your micro SD card. The micro SD card has to be plugged into the computer or the laptop that you are using. Okay, and then choose the storage card, click the next. The keying over here, then the system will ask you, would you like to apply the operating system customization settings? You please click yes, okay? Please click yes. Once click yes, then you're going to set the host names. You will just enable the SSH. So over here, we will just, use the password authentication, which is the password you use, set it the username and password, okay? Over here in the example is the Pi and the password for you log into the Linux system, okay? And also for that SSH, okay? So over here, I forgot to mention, okay, what is the SSH? Okay, because headless we want to remote logging. So SSH is actually stands for the secure shell. Secure shell. It is encrypted alternative to the telnet, so you can remote log into the system through a port 22, through the default port 22, but it's secure. The connection are encrypted. Okay, so there's two ways you can do it. One is use the password authentication, which is easier. So I would recommend you just using this one. And later on, if you want to set up the public key authentication, then you can do that too. Okay, and so you can set up the SSH and also configure the wireless LAN at this stage. So that's easy, okay? Once you finish the save and click write, begin writing the data to the SD card, okay? So it will write into the SD card. So once you're finished, then you plug the SD card into the micro SD slot, right? Of all those boards has that micro SD slot, as we see over here. I can see over here, either this one, or if you want to, you want to see over here, there also has a micro SD card slot. Okay, just plug it into there and then power it on. Okay, then power it on, then the system will getting started. Okay, once the system getting started, you could, the next step you needed to obtain is IP addresses. IP addresses. So those are alternative ways to set up the SSH and the wireless LAN. That's in the case you haven't configured it, but you already burned and that micro SD card. You can go through this way too, okay? Either you can reburn it and reset it, or you could just write an empty SSH file, SSH file, into the boot folder of the micro SD card. For the wireless LAN, then you can also configure one of the WPA underscore the supplicant.configure file under the boot folder. Okay, both of them. I showed the one examples of this SD card. Sorry, that WPA supplicant.configure file example. So you can just showing Basically, you could have the password and then PSK, and then for those enterprise network, which you're going to need including the identity, so your username and the password. So over here, you only need including the network name. Okay, so mostly like if it's not enterprise network, then you don't really have those Redis servers configured, then you will just using the first one, the top one. Okay, either way. So this is the alternative ways to configure the SH and the wireless LAN. After you burn the micro SD card, as I mentioned earlier, you will just power it on. Okay, turn it on and power it on. And the next step is you want to find out the IP addresses. In order to connect it, you have to find it. So two conditions. If you're already connected to a monitor and a keyboard, the system will be just turned on. And then just like a typical of that Windows system or that the interface is really similar to whatever desktop, Windows or the or iOS system. Okay, and then you will turn on either, terminal, Windows, open this, you could type in some of the command, like for example, ifconfigure, and then you will be able to find out its IP address. So this one, in this example, 10.28.192.65 is the IP version for IP address, and then just write it down. Later on, you need to use it. Or alternatively, you could also use the hostname -i. It will also tells you, okay, that's uppercase I, will tells you your IP addresses. Okay, so this is about the configuration. So if you don't have that monitor to access, another way you can obtain its IP address is log into your router. Okay, log into your own router, and then you try to find out that host name that you write into your operating system. So identify what's the IP corresponding to it. Okay. And once you have that, then you can connect it through on your computer. So that is already powered on. And in your computer, you use this command, SSH, and then your username at the IP address. Okay. So that's why we need the IP address. This is the one way, then we will get into the system. So once you log in, that's a Linux system that you could utilize. We will list some of the command. You can try to use it in later slides. Okay. You could also connect it through some of that, use some apps. So for example, you can install like a PuTTY, okay? And then so that you can save the sessions, you enter the IP address and name and save the sessions so that you don't have to every time type into the IP addresses, okay? So this link is about public key authentications, okay? Change the Wi-Fi configurations. So if you have a multiple Wi-Fi you want to configure, so in case one of them is not working, I want to use another one, you could do that. And you can also set the priorities, okay? Large number of the priority, they has a higher priority. So, so for example, in this case, we set up 3 networks can be connected. And then the network -5G then will be connected because they have the highest priority if all three networks are available. Okay. Another thing we want to mention later is you could also enable the VNC or the virtual network computing. Though I think I don't have the time to talk about it. This is once you enabled, you could remote access to it. So it's like in your own computer, you can access that desktop environment GUIs, okay? I think for the most applications, you don't really need to set up the VNC for the IoT applications. Because the node itself is not the best option to provide the GUI. Okay, not the best to provide the GUI. Okay. Here's a list of the commonly used Raspberry Pi, the command, the Linux command. And then you can try it out. It won't hurt anything. But and then if you are familiar with the Linux command, then it's not an issue. Otherwise, you can try those commands to getting the related informations. In the later workshops, when we need to use it, we will also have a more details application and demonstrations. Some more comments. Okay, so next portion of the last part I will talk about is the Arduino board. Okay, Arduino is also really popular electronic prototyping platform with both open source hardware and software. And the community is pretty active. So over here is showing some of the boards with the wireless and or the Wi-Fi or the Bluetooth and capabilities. Okay, for example, the Arduino MKR Wi-Fi 1010. Okay, this is the one of the node that I actually used. This one has both that 802.BGN capabilities and also the Bluetooth. So this is one of the boards that we used. And then Arduino Nano 32 IoT, and then those are either Bluetooth or the Wi-Fi's. Okay, you can see over here, Nano 32 and Nano Bluetooth, which is BLE is for the Bluetooth, BLE sensor Bluetooth, but also including some sensors already. Okay, so there's different options that you can use. For the Nano RP 2040 is very similar to the Raspberry Pi Pico, which is Raspberry Pi Pico compatible. Okay, 32, this is for the Wi-Fi. So this is some of the boards. So for all the Arduino boards, those does not have an onboard operating system like a Raspberry Pi. Those microcontrollers, we typically use the Arduino development environment or IDE, which is free available. You could download from the Arduino software for free, okay, for free, and then it can work on Linux, and iOS or Windows. Okay, the interface is pretty straightforward, very easy to use. And I also listed all the details about how you can set up the different things, which if you want to use, then you can later on follow the steps, okay? Then I also would like to talk a little bit about some additional boards available. Well, Wi-Fi is not available, okay? So over here, the Arduino MKI narrowband IoT. This is utilize either that the 5G narrowband IoT standard or that LTE machine. Those are for the long distance connections. They can support the data rate up to 200 kbps. So it's not really high, okay, not really high. For most of the IoT applications, no, it's sufficient. It's sufficient. You could also have some of the other boards, for example, this Arduino SIM MKR GSM 1400 serial kit. So they can transmit the data over much longer distance, okay? Well, the Wi-Fi is not available. And another one, this Arduino MKI WAN and 3010, this is support the LoRa connectivities. And that is another standard that proposed by the LoRa consortium. And that is supported really ultra low power consumption. And also the data rate support is relative low, okay, relative low, but they can transmit data over a much wider range of the distance. Okay, so those is about some Arduino board. Another thing I want to mention is for the Arduino IDE, the system not only support the Arduino board, but also many other board developed by the other community users. One of them is the Node MCU. I would like to mention that this is a ultra low cost IoT devices. They could range, you can easily purchase like for the Amazon. Sometimes it's like one of these just single board, $3-4. Okay, like six of them for $18. So it's very affordable and then cost effective. If you want to many of those nodes for your applications. Okay, the Node MCU is based on of the ESP8266. That is integrated MCU with the Wi-Fi capabilities. It is a very popular one, not only for the Node MCU. You're going to see many nodes is based on the ESP8266. So here's how you can find out this, the Arduino IDE. Also, now the Arduino provided a web edit that you can use. A web edit that you can use. Okay, so in this slides is showing the examples. You can easily to work with it. Okay, good question. I saw there's, I almost done with that presentation. Okay, there's one question asking you, do we need the Raspberry Pi for that? For the later workshops, not the exact next one. It will be nice for the next one, but for the previous, the first 4 is like the cases that, most of the introduction for the different components. But for the last 4 workshops, we're going to use these components to build systems. Okay, so you don't have to purchase now, but I would recommend you if you can have one devices available for you, and then it will be easy to follow the process. Okay. Okay, so last question we look at. Yeah, okay, so what's wrong? Okay, so this is another poll. Let's see for the low data rate, but the battery powered IoT devices, if it's deployed in a remote area, and which board that you would choose to use. Yeah, most of them will choose the narrowband 1500, Raspberry Pi 0W. Okay, yeah. I said in a remote area without Wi-Fi available. So you probably want to change your answer, right? We would see what? That Arduino, MKR1, or the narrowband 1500, those 2 are probably the better options. C and D will be the better options. Because A, B, and E all use what? Or use Wi-Fi's. They have a Wi-Fi or Bluetooth, right? And then that's not always available in the remote areas. Okay, so this is some of the references, and I think I'm finished. Any questions? And then we will have a survey right after this presentation. So please give us some feedbacks. Thank you very much for listening. Any questions? If not, then I will. I think I answered a few questions during the presentation. If not, then thanks for joining the workshop. We'll see you next week. Thank you. I will send out the presentation handouts too. Yeah, sure. Okay. Yes, I can get the information. So pretty much the last four workshop, if you see that, that's the project you're going to create. I will provide also the example code. Okay, thank you. Bye-bye. See you next week.